Hello everyone, welcome back. Today we're tackling a really interesting math problem from Leetcode called smallest integer divisible by k. It sounds a bit academic, but it's actually a great exercise in understanding modulo arithmetic and optimization. If you've ever wondered how to handle huge numbers that don't fit in standard integer types, this problem is perfect for you. We'll break it down step by step, so let's get started. Here is the problem. We are given a positive integer, let's call it k. We need to find the length of the smallest positive integer, let's call that n, such that n is divisible by k. But here is the catch. N can only contain the digit 1, so n looks like 1, 11, 111, and so on. We need to return the length of this number. If no such number exists, we return -1. Let's really understand what we're looking for. We aren't looking for just any number divisible by k. We are looking for a Repunit, a number made entirely of ones. We start small with 1, then 11, then 111, and keep adding ones until we find a number that k divides perfectly. The tricky part mentioned in the problem is that n can grow incredibly large, way bigger than what a standard computer variable can hold. This is a hint that we shouldn't actually build the number n. Let's walk through a simple example, with k equals 3. We want to find a number made of ones divisible by 3. First, we check the number 1. 1 divided by 3 leaves a remainder of 1, so that's not it. Next, we try 11. 11 divided by 3 is 3, with a remainder of 2. Still not 0. Next, we try 111. 111 divided by 3 is exactly 37, with a remainder of 0. Since the remainder is 0, we found our number. The length of 111 is 3 digits, so our answer is 3. Before we jump into the code, let's think about when this is impossible. Our number n is made only of ones. This means the last digit is always 1. Can a number ending in 1 ever be divisible by 2? No, because it's always odd. Can it be divisible by 5? No, because multiples of 5 end in 0 or 5. So if our input k is a multiple of 2 or 5, we can immediately say it's impossible and return -1. This is a crucial observation. Just a quick heads up. We'll be walking through the solution using Python, but don't worry if that's not your main language. I'll be showing the full code for other popular languages like Java, C++, and JavaScript towards the end of the video. So how do we solve this without storing a massive number that crashes our computer? The editorial suggests an approach called checking loop. The core idea is that we only care about the remainder. We don't need the full number n to find the remainder of the next larger n. We can take the current remainder, multiply it by 10, add 1, and then take the modulo with k. This keeps our numbers small. If we keep doing this and the remainder becomes 0, we win. If we see the same remainder twice, it means we are stuck in an infinite loop, and the answer is impossible. Now we can make this even smarter using the Pigeonhole Principle. Think about it. When we divide by k, there are only k possible remainders, ranging from 0 to k minus 1. This means if we try building our number n by adding ones, and we do this k times, one of two things must happen. Either we hit a remainder of 0, or we start seeing remainders we've seen before. If we repeat a remainder, we are in a loop and will never hit 0. Therefore, we only need to check a length up to k. If we haven't found a solution by then, we never will. Okay, we've talked about the big picture and the logic. Now let's see what this looks like as actual code. I'll put the full solution up on the screen first, and don't worry after that, we'll walk through the most important sections together. Alright. Here's the Python code for the checking loop approach. It is surprisingly short. We basically implement that optimization we just discussed. We loop a specific number of times, update our remainder math, and check for success. Let's break it down piece by piece. First, let's look at the loop. We iterate with a variable called length n, starting from 1 up to k. We use k plus 1 in the range, because Python ranges exclude the upper bound. This goes back to that pigeonhole principle. We know for a fact that if a solution exists, its length must be less than or equal to k. This line is the heart of the algorithm. Instead of calculating n times 10 plus 1, which would be huge, we take the remainder times 10 plus 1. Then we immediately mod by k. This creates the remainder for the next number in our sequence, like going from 1 to 11, or 11 to 111, without ever dealing with integer overflow. It keeps our values manageable. Finally, inside the loop, we check, is our new remainder 0? If it is, congratulations, we found a number made of ones that is divisible by k. We immediately return length n. If the loop finishes all k iterations, and we haven't returned yet, We know it's impossible, so we return -1. So how fast are these solutions? As the analysis shows, the time complexity is big O of k. This is because in the worst case, we run our loop exactly k times. For space complexity, it's big O of 1, or constant space. We only store a few integer variables like the remainder and the length, regardless of how big k is. It's extremely efficient. Alright, that covers the main solution in Python. As promised, for those of you who code in other languages, I'm about to show the full solutions for Java, C++, and JavaScript. I won't be breaking these down, so just pause the video on your language of choice to check it out. Alright, as promised, here is the full solution in Java. You can pause the video here to take a closer look at the implementation. I added the explicit check for 2 and 5 here for clarity. Next up, here is the C++ version of the solution. It looks very similar to the Java version. Again, feel free to pause and review the code. And finally, here is the solution in JavaScript. Hopefully seeing it in a few different languages helps solidify the concepts. So, let's wrap it up. We learned that we don't always need to store the full number to check for divisibility. Calculating the running remainder is enough. We also used the Pigeonhole Principle to prove that if a solution exists, we'll find it quickly, specifically within k steps. This allowed us to write a super clean, efficient loop. Alright, before we finish, I want to quickly show you a personal project I built to solve a problem that always drove me crazy. It's an app called My Daily To-Do. My biggest frustration with every other to-do app was retyping the same things every single day. Go to the gym, review code, work on the daily Leetcode problem. You know the drill. So, I built my app around one simple but powerful idea: separating your routine tasks from your one-off tasks. Routine tasks, marked with the little refresh icon, automatically reset for the next day. One-off tasks, like ship new feature, get the little puff of smoke icon, and they disappear for good once you're done. This small change turns a dumb checklist into a smart scheduler. If that sounds useful, you can try it right now on the web. The link is in the description. And one more thing I want to make super clear. Right now, as a thank you for being an early supporter, the app is 100% free. There are no ads, and no subscriptions whatsoever. This means you get access to everything, including really powerful features like presets, which let you save entire task lists and load them with a single tap. Now down the road, creating new presets will likely become part of a premium plan to help support the channel. But, and this is the important part, any presets you create now, while it's all free, are yours to keep and use forever. So it's the perfect time to check it out on the web, play with all the features, and build out your perfect setup at no cost. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the playlist tab and find a playlist that fits your goals. Also, if you're looking for even more Leetcode problems beyond the daily challenge, I've started a second channel called Leetcode Unlocked. It's where I'll be posting solutions to a ton of other problems. So if you're serious about your interview prep, be sure to check it out. The link is in the description below. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. If you want to support the channel, a few people have asked how I plan my solutions. I'm a big fan of sketching out the logic and data structures on a tablet before I code. It really helps. I've put affiliate links in the description to the tablet I use and a few other good options. Using those links doesn't cost you anything extra, but really helps me out. Or, if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.